So in the last video, we created a push head function using the address of our head function, a pointer that we created in our main function. The push head function basically adds a node at the beginning of our list. There is a different way to code this push head function without using a double pointer, and I'm going to show you how to do just that. So let me create a function prototype. I've kind of cleaned up the code a little bit. Typically I like to add comments on top of my functions so that way I can easily find where they're at. It's just a little personal style on my part. So I'm going to create it under this, and we're going to call this, it's going to be a node type, but the one major difference is I am going to create a function that will refer to the pointer node. And so we're going to just call this push head, we'll just call it 1. And then the parameters will be node, but instead of a double pointer, we're just going to need a single pointer, and then we'll keep the data the same. So this will be our function prototype. And I'm going to copy, put it at the bottom. So now let's come up with a definition and also explain the logic. In this particular function, we want to return a pointer to our head pointer that we created in main. In our main function, we create a node pointer head that we set to null. Well, this head pointer has an address, and so let me create a stack frame or an activation record for main. As we know, a pointer is a variable that holds an address, or it's an address variable. And this head will hold an address of anything that we create in the heap. So nodes that we create in the heap. Pointers can also hold addresses of anything we create in the stack. For this tutorial, I'm really going to focus on how our pointers are used to store addresses in the heap memory, and to also use those pointers to be able to manipulate and change nodes or values or modify our nodes or our list using pointers. This particular function, notice how I have a pointer. So this function will return a pointer to a node. In other words, this function will return an address. In short, we want to return a pointer to the head of a list, or to our head list, which is this in our main. And again, this particular head is a pointer to a heap. And since this head is a pointer to our heap, it is already a memory address. We can return an address to this function. The return type is a pointer, which basically means we are going to return an address. So let's come up with the definition of our function. So the first thing we want to do is create a new node. And remember, our new node has to be a pointer because the only way we can access a heap is through pointers. And we're going to malloc the size of our node. Malloc returns a void pointer, so it's best practice to typecast it. We're going to typecast it as a node pointer. And then we're going to do our error check, similar to how we did our push head functions with the double pointers. We're just going to say if new underscore node is null. So in other words, if our heap is full, meaning there's no more memory that the heap can allocate to us for our new node for whatever reason, we're going to printf error memory not allocated, and then we're just going to exit our function with an exit 0 code. After we get past that error check and our memory is allocated, we are going to assign the data, and we have to use the arrow operator because we're using pointers, to the heap data, and then we're going to set our next link of the node to null. So I'm going to draw what's happening in lines 75 to 82. We haven't called this function yet, but once we go into our pushhead function, or our pushhead 1 function, we create a variable called new node. And this new node is a pointer. After we get past the error check, the heap allows us to generate a node in the memory. A node is created. Let me give it an address of 0x100. This new node pointer variable will point to our new node in the heap. And this new node now will hold the address of 0x100. And when we enter data, let's just say we enter a 15, and it comes from our parameter. So once the arguments are entered. In this data parameter, we're going to allocate whatever is entered in that data by the user and assign that to our data over here. And then our new node next, our next link, which is this, is just going to equal null. Now we have to address two conditions. So the first condition is if our list is empty. How do we know that our list is empty? Well, we know because our head is pointing to null. If head, and in this case we don't have to put a star in front of head because a pointer will hold the address of this head. And so we don't have to put a star. Now if we had a double pointer, then yes, we would have to put a star. If head is null, then what we want to do is we want to assign a new node to head. In our pushHead1 function, we create a head variable. And here we assign new node to it. So in other words, it's going to hold the address of 0x100. And after lines 87, we officially have one node on our list. So the second condition that we have to address is, what if we have one or more node currently in our list? Else, we're going to assign the new node's next link to our head node. In this case, we created a node. If we already have at least one or more existing nodes, we create our new node. So let's just say we enter the data 25. What happens is a new node is created, and we're going to enter 25, and this is the address 0x200. Our new node is created, and based on lines 75 through 81, we enter our data, and this is null. Now our new node is pointing to this newly allocated node in the pointer, and it's holding the address 0x200. And what we want to do is our new node next, which is this thing that's currently pointing to null, we want to point that to head. Well, where is our head pointing to? Our head is currently pointing to our first node. And so we're going to point this next list to our head. So now this next link is holding the address of 0x100. The last thing that we have to do is fix the location of our head. Head means that it should always be pointing at the very first node of our list. Let's go ahead and change. Now that we're linked up to our head node, we can go ahead and change our head to point to the first node. We're going to assign our newly created node to our head. Pictorially, our head now will hold the address of 0x200. So now our head is pointing to our head node. And if we create a new node, it's the same process all over again. So let's just say, let me create another node. This is currently pointing to null. Our new node is now created, and it holds the address of 0x300. 85 through 87, that condition is false, so the compiler will skip that. We go straight to line 90, and this next node, which is currently pointing to null, is now going to point to our head, and so now this will hold the address of 0x200. On lines 93, we are going to assign the address of this new node to our head, so now our head will be pointing to our new node that we created. Now the order is correct. Our head is pointing to the first node is pointing to the second node is pointing to the third node. That's basically the algorithm. Now here's the difference. Because we have this pointer, we're returning a pointer, we have to return an address and assign it to this address. So what we want to do is we want to return head. We want to return head. And what is head? Head is an address. And what are we returning? A pointer. And what is a pointer? An address variable. When we return to our main function, and I commented out the push heads or the old function calls, since we didn't modify this head by using a double pointer, we have to return an address to it. We want to say head and assign our push head. Our first argument will just be head, and our data, let me just mirror our illustration to the right, is going to be 15. This function is returning a pointer, which is an address, and we are going to assign that address into this head pointer. Let me compile, and there's our first node of our list. So in the illustration, I entered 25, so let me mirror that. So the output of this should be 25 and 15, and let me compile that. And there it is. And then finally, let's add our last one, which is a 40. 40, 25, and 15. Now, can we combine the two functions, the regular push head and the push head 1 function that returns a pointer address? Yes, we can. The answer is sure. Since we already have 15, let me change this to 75. Okay, so the output, and remember, we're adding to the beginning of the list. So our output should be 40, 25, 15, 75, 10, and 5. And let's compile and run. So 40, 25, 15, 75, 10, and 5. So I hope that you were able to understand this function and how it's different from our push head function. In our original push head function, we are using a double pointer because we are directly passing the address of our head pointer in main. We're using the address, the actual address of head that is in our main. In our second function, we are returning an address. And so we are assigning an address to our head function. Whatever address is generated inside of the function, that address is returned. And how is that possible? Well, it's possible because we are generating the nodes in the heap. And whenever you generate a node in the heap, they are not popped off like they would be if they were in a stack. And so, for example, every time we call the function pushhead1, and every time we complete that function, it is popped off. And whenever we call it again, in this case we called it 3 times, an activation record is created, and then after we complete that function, that's popped off. We call it for a 3rd time, a 3rd activation record is created, and after we complete that function, that is popped off. But what isn't popped off is the nodes that we've created in the heap. The only way we can get rid of these nodes is if we manually delete it ourselves. And that's how we are able to save the addresses of this, or use the addresses of these nodes. And in particular, the head function should be pointing to the first node, which is 0x300. Now that can be any arbitrary memory in your system. I'm just using this to simplify the addresses. But that address is returned to our head pointer, which is an address variable, and it's able to generate or create our linked list by returning this address because our linked list is in the heap, and until we delete them, they will be there until we get rid of them.